Hello everyone, my name is Evgenia Shepilina and here's my wind tunnel project. We can all clearly see that our coefficient of lift increases with increase in angle of attack. As we can notice right here, at the x-axis, we have the angle of attack, in its degrees. And we can see that the line of coefficient of lift keeps on increasing with an increase in angle of attack. That indicates to us that when we increase an angle of attack in our airplane, we also increase the coefficient of lift. That is also obvious by the lift formula that we have learned earlier in the class. With a drag, it's a little bit more complex because we have two major types of drag, such as parasite drag and induced drag. As we learned earlier in the course, induced drag increases with the increase in lift, and we know lift increases with a higher angle of attack. Once again, we can note the angle of attack on the x-axis right here, and we can see that angle with increase in angle of attack right here, our drag curve keeps on rising, and that is because primarily due to induced drag, which is a direct byproduct of lift. This area right here typically represents maximum lift to drag configuration. If we had a lift curve right here as well, that would represent the best glide of the airplane. At the same time, with the negative angles of attack, we would still have a lot of drag as well, and primarily that will be the parasite drag. That is basically the form or interference or skin friction drag of the airplane, which plays primarily the major role during the slower airspeeds. So the best drag configuration for a typical airplane is at somewhat low angles of attack. Will give you the best drag configuration to maintain typically a cruise flight or the best glide right here. Alright, well, this is my presentation, my understanding of the graphs. Thank you very much for your attention, and I hope you have a great night. Thank you. Goodbye.